Hello guys, welcome in today's session. I am Professor Fayyaz Tawadi from Department of Mechanical Engineering. In today's session, we are going to learn how to find the magnitude and direction of gyroscopic couple in the mechanical application of mechanical system in which axle rotates in the bearing. This is our problem number 1 from unit number 6 gyroscope from theory of machine subject. The problem statement is in front of you. I read the problem statement. A uniform disc has a mass of 6 kg and a radius of gyration 75 mm. It is mounted centrally on a horizontal axle of length 150 mm in bearings. The disc spin about its axle with a constant speed of 1000 rpm anti-clockwise when viewed from a right-hand side bearings. The axle recesses uniformly about the vertical axis at 80 rpm in anti-clockwise direction when seen from top. Find the resultant reaction at each bearing due to mass and gyroscopic effect. This is the application in a mechanical system in which we have to find out the resultant reaction at each bearing due to mass and gyroscopic effect. So first of all, we have to find out the magnitude of gyroscopic couple, and second we have to find out direction of gyroscopic couple, because the gyroscopic couple has a vector quantity, so it has magnitude as well as direction. And after finding the direction, we have to find out the reaction, a resultant reaction on each bearing. This is our third step. So data is given is in front of you. Mass of the rotor or rotating disc is given 6 kg. A radius of gyration, which is denoted by K, which is given A is 75 mm, and that I will convert in meter point by dividing 1000. So it will be 0.075 meter. Span between two bearings and or the distance between two bearings which are apart from each other is 150 mm. So the conversion of 150 mm in meter is 0.15 meter, that I got by dividing 150 by 1000 mm. RPM of disc is given 1000 RPM. The rotation of this rotor or uniform disc is given 1000 RPM. So I will convert that N into omega, angular velocity, which is formula, omega is equal to 2 pi n upon 60. So after putting the value of N as 1000 RPM, 2 pi into 1000 divided by 60, I'm getting the value of omega here 104.7197 radian per second. And angle and velocity of precession is given. The axle precesses uniformly about the vertical axis at 80 rpm in anti-clockwise direction when seen from top. So NP, precession velocity of the system of a rotating disc, is given 80 rpm. So omega p is equal to angular precession velocity. Angular velocity due to precession. So omega p is given 2 pi into 80 rpm divided by 60, 2 pi n upon 60. So the value of omega p I am getting here 8.3775 radian per second. This is our conversion for solving the numerical. Now the first first step is to calculate the magnitude of gyroscopic couple. As we learned in previous session, the formula to find out the torque or magnitude of gyroscopic couple is I omega into omega p in Newton meter. So we convert all the length which is given in mm in meter. Already. So I is mass moment of inertia, omega is the speed of rotation during spinning about the spin axis, and omega p is the angular velocity during precession, omega p. So formula to find out the magnitude of gyroscopic couple is equal to I omega into omega p. So putting the values of I, mass moment of inertia of the disk is equal to I is equal to mk square, as you learn in some subjects, strength of material subject. K is a radius of gyration and mass is mass of the m is the mass of a rotating disk or rotor. So mass moment of inertia is mk square. So putting the values of mass in kg, don't convert that mass into Newton. Okay, so mass of the disk, rotating disk is given 6 kg into a radius of gyration. Radius of gyration is given 75 mm, which I convert here in meter by dividing that 75 into dividing by 1000. So value of k is getting here 0.075 in meter. So finding the values of solving the equation, I am getting the value of I, mass moment of inertia, is 0.03375 kg meter square. Kg is the mass in of the disk in kg, and radius of gyration is in meter. So value of I is getting here 0.03375 kg meter square. This is the value of I. Now omega we have already found out, and omega p also we have already found out. Omega is this value and omega p is 8.3775 radian per second. Putting the values of omega and omega p, I have found out the value of T here. So magnitude of gyroscopic couple is putting the value of I, omega in radian per second, omega P again in radian per second. So after solving this equation, I found out the value of torque, magnitude of gyroscopic couple is equal to 29.6085 Newton meter. After solving up to here, I will got 4 marks. Okay, now the main is to find the direction of gyroscopic couple, which is for 8 marks. So total problem is of 12 marks in examination. Now, as we learned in previous session, this is the procedure to find out the direction of active and reactive force, that is gyroscopic couple. Already you read that all the steps. I am directly starting step number 2, that is mark the direction of a reactive gyroscopic couple. We have to find out the direction of gyroscopic couple. So this is the figure. 2 bearings are given which are 150 mm apart from each other, which is given in problem statement. So converting that in meter, 0.15 meter, 150 mm is given. So convert that length between the bearings, 2 bearings is given 0.15 meter. Okay. Now in problem statement, which is given the disc spin about its axle with a constant speed of 1000 rpm anti-clockwise when viewed from a right hand side bearing. Now first we have to decide which is right hand side bearing, which is left hand side bearing. So if you observe that complete system, mechanical system from this direction, now you are looking that bearing, this is the isometric view, of the mechanical system which is given in problem statement. So this is the position of looking the system. This is the front view. Front view. So when you are looking that system from this direction, this will become your right hand side bearing, and this will become your left hand side bearing. So bearing B is the direction of a right hand of the observer. So from the right hand side bearing, if you observe that system, the rotor is spinning in anti-clockwise direction on the axle, which is given in problem statement. So this will become your right hand side, and the next thing is given here. The axle twists uniformly about the vertical axis. The axle recesses uniformly about the vertical axis at 80 rpm in anti-clockwise direction when seen from top. Concentrate on this anti-clockwise direction when seen from top. So if this will become front view, as you are looking now, this will become front view, and this will become a right hand side of this system. So the precision of this complete system you can see from top view. So this will become top view, in which you can see the precision of complete system. And this complete system is recessed about the vertical axis in anti-clockwise direction. That is given in problem statement. So this will be omega p, and this will be omega. Spinning about the axis is omega, and recession around the vertical axis is recession, and a rotation of that complete system around the vertical axis that you can see from top view is nothing but recession. That is nothing but omega. Now, as per the first step to find out the direction of active couple is that I read the first step. Draw three views of a rotor showing direction of rotation in three different planes by first angle projection method. You have to draw three views of a rotor in which you have to show the direction of rotation of that rotor. So this will be front view, this will be side view, and this will be top view. So you have to draw in first step three views of a rotor in which you can see the spinning, recession, and gyroscopic couple. So I drawn here three views of the rotor. So this will become front view. If you are looking at disc from the front view, you can see that disc as a rectangle. A rectangle. This will be the front view. And by first angle projection method, you have to draw the top view exactly below the front view. So if you observe that disc from top, you can see that disc as a rectangle. So this will be the top view, and looking from right, in which you can see the actual rotation of the disc, this will be become a right hand side view. A right hand side view, which you will draw left side of the front view, because in first angle projection method, a right hand side view you will draw left to the front view, and left hand side view you have to draw a right side of the front view. So a right hand side view you will draw left of the front view, exactly left side of the front view. So this will be front view. So this will become a right hand side view. So this is front view, this is top view, and this will be the right hand side view, which you have drawn left to the front view. Okay, now we have to decide what is the direction of rotation of the disc. Okay, so first step is draw three views of rotor showing direction of rotation. After drawing three views of the rotor, the next step in this to show the direction of rotation, showing direction of rotation. So in right hand side view, from right hand side view, you can see the actual rotation of the disc. So from a right hand side view, the disc is rotating in anti-clockwise direction. So this will be the anti-clockwise direction, which is omega. And if you see from front view, the direction of rotation, you have to show the arrow by downward direction. Downward direction. And if you see from top view, the direction of rotation, again from top, the arrow will show in downward direction. You have to clearly understand that step. Okay, from a right hand side view, you can see the actual rotation of the disc, which is in anti-clockwise direction. So I draw the anti-clockwise arrow in side view. In front view, the arrow will show downward direction, and in top view, again the arrow will show from top to bottom, that is downward direction. Now, which is spin plane, which is precision plane, and which is gyroscopic plane? The plane in which you can see the actual rotation, that plane is a spin plane, as we learned in previous session. I will share the link of that previous session. Okay, the rotation in which the plane in which you can see the actual rotation, whether it is rotating clockwise or anti-clockwise direction, that is a spin plane. So in side view, you can see the actual rotation, whether it is rotating anti-clockwise direction or clockwise direction. Here in this problem, it is rotating in anti-clockwise direction. So in this plane, that is in side view, you can see the actual rotation. So that plane is a spin plane. That plane is a spin plane. From top view, the complete system is recessing. From top view, you can see the rotation of that complete system around the vertical axis. So top will become a precision plane. That complete rotation around y axis in anti-clockwise direction, which is given in problem statement, that complete rotation in anti-clockwise direction, you can see from top view. So in top view, you can see the precision. So top will become precision plane. You have to clearly identify which plane is a spin plane, which plane is a precision plane, which plane is a gyroscopic plane. If you make mistake in finding the spin plane, precision plane, and gyroscopic plane, your complete problem will wrong in further step. And the remaining third plane, which is mutually perpendicular to both the plane, is a gyroscopic plane. So this front plane will become a gyroscopic plane. Front view of the disc is become a gyroscopic plane. Okay, clear? Clear, understand this. Left hand side view, right hand side view will become a spin plane. The precision you can see in top plane, top view. So top will become a precision plane, and third mutually perpendicular plane will become a gyroscopic plane. In this plane, we can see the active and reactive couple. This is first step. Second step, draw starting and new position of a rotor in precision plane. Draw starting and new position of rotor in precision plane. Second step. So this will become our first step, in which we drawn the three position of a rotor and showing the direction of a rotor as per problem statement. The second step is to find the first position and second position in precision plane. This is our precision plane as per given condition. Okay, so this is the direction of a rotor in precision plane. So by a right hand thumb rule, the curling finger is showing the direction of a rotation. The tip is going downward. So the arrow direction is again here downward. So the whatever the direction of arrow in precision plane, this will be the position of tip of curling finger. So when the curling finger is showing the direction of rotation, the thumb is showing the direction of vector in first position. Okay, then the precision is taking place around the bearing A. Okay, and it is in anti-clockwise direction. Precision is taking place in anti-clockwise direction, so this will be become a second position. Second position. Okay, so I will draw the vector in precision plane. So OA, this is the initial position of that rotor. OA, this is the first position, but the direction of arrow I am showing here, whether from O to A or A to O. So the curling finger is showing the rotation of rotating disc. At the same time, thumb is showing the direction of vector as per right hand thumb rule. So direction of the thumb is from left to right. Right side the thumb is going. So the direction of vector is from O to A. O to A. Now in second position, now precision is starting. Precision is starting and precision is as per given in problem statement, it is in anti-clockwise direction. So second position will be like this. This is first position and precision is starting in anti-clockwise direction from given in problem statement. Okay, so this will be the second position. Now the disc is precessing like this. Rotor is precessing like this. So we have to find out the direction of vector in second position. OB. This is O and B is the second position. Now again by a right hand thumb rule, the curling finger, the tip of curling finger is showing the direction of spinning of the disc. Okay, so arrow is showing again downward direction, as here also arrow is showing in downward direction. Okay, at that time thumb is showing the direction of vector in second position. So direction of vector is in the direction of thumb. So direction of this vector OB is showing from O to B. O to B. Okay, O to B. So resultant vector is A to B from first position to second position. A to B. A to B. That all figure you have to draw in examination. Now the next step is to find the direction of vector. Find direction of vector OA and OB by right hand thumb rule that we have already found out. Join vector AB which shows the direction of torque vector that we have to find out. Direction of torque vector. The magnitude already we have found out by the formula I omega omega P. Now we are finding the direction of this torque vector in precision plane. In precision plane. So this is in precision. These all vectors are in precision plane from this plane. Okay, A to B. So this again, though we have to find out the direction of the vector. We have already found out the direction of vector. Already found out. Now we have to find the rotation of that vector AB. OB. Now from fourth position, see this is the torque A to B. Okay. Now the thumb is showing the direction of vector. In reverse direction we are thinking. The thumb is showing the direction of vector. At that time curling finger is showing the rotation of that vector, rotation of that disc. Okay, this curling finger. So if you look from bottom to your hand of the curling finger, okay, you can see that curling finger is rotating in clockwise direction. From looking in this direction, you can see your hand also. You put your hand like this, and to your hand you see from bottom side. Why bottom side? Because we have to convert that vector in gyroscopic plane, which is the next step. See here, fourth step, conversion of torque in couple in gyroscopic plane. By right hand thumb rule, thumb shows the direction of torque and curling finger shows active gyroscopic couple. That active gyroscopic couple we have to transfer in the gyroscopic plane by looking from bottom. Okay, because active couple and reactive couple is acting in gyroscopic plane, and we have to find out the direction of a reactive couple. So first we have to find out the direction of active couple, and the reactive couple is exactly opposite of active couple. Okay, so the next step is transfer that active couple in a gyroscopic plane. So which is the gyroscopic plane? This is the gyroscopic plane. This is gyroscopic plane, this is spin plane, and this is precession plane. So already we have found out the direction of resultant vector AB. Okay, now we have to convert that resultant vector in, which is in precision plane, that we have to transfer in gyroscopic plane. So that direction I will see from bottom to my right hand. So the direction of thumb is showing the direction vector of AB. At the same time, this tip of curling finger is showing the direction of active couple. You look from bottom to your right hand. By this position, you can see from bottom your curling finger is rotating in clockwise direction. So I will draw the active couple in clockwise direction. When active couple is in clockwise direction, I will draw the reactive couple in anti-clockwise direction. We are concentrating on reactive couple. We have to find out the direction of reactive couple. So we are done all this procedure. Okay, this is for 8 marks. You don't make mistake in finding the direction of reactive couple. Okay, a reactive couple which is rotating in anti-clockwise direction. Why? Because active couple is rotating in clockwise direction. Okay, clear this point. Now after finding the direction of reactive couple, we have to find out the resultant reaction at two bearings. Okay, this was our step number 5. Now come to the actual problem statement, which is asked, calculate the reaction of each bearing. Now this is the rotor, these are two bearings. Okay, and axle is rotating in the bearings. We have to find out the reaction at E and reaction at B. Okay, the weight of the rotor is given. Weight is equal to mass into gravitational force. Mass is given here 6 kg. Okay, and span between two bearings is given 150 mm. So this will become 75 and this will become 75 mm. So this will become 0.075 meter and this will become 0.075 meter, the distance of each bearing from the rotor. Okay, now you learn the equilibrium condition in engineering mechanics in second year. So I am taking the summation of all the forces. Okay, Fy is equal to 0. Okay, summation of all the forces in y direction is 0 and is equal to Ra, a reaction at B in upward direction. I will take positive. A reaction at B, again it is moving upward direction. Okay, so it will be a positive, and weight is acting downward direction, so weight will be minus, because it is moving in downward direction. It is acting in downward direction, so both are is acting on upward direction, so it will be plus. I'm considering it will be minus. So Ra plus Rb is equal to mg. So value of mg is equal to 6 kg is given mass of a rotor into 9.81. So Ra plus Rb is equal to 58.86. Okay. Now taking the moment around A, taking moment of all the forces around A. So summation of moment at A is equal to 0 is equal to mass into G in clockwise direction. R at A, force into perpendicular distance. So this will be a moment, force into perpendicular distance. So R into A will be 0. Okay. Weight is moving clockwise direction. Mass into gravitational force into perpendicular distance. So moment at A of the weight is equal to W into 0.075. Okay. Minus T. T is a reactive couple, which we have already found out in previous step. A reactive couple. We are interested in reactive couple. Okay. A reactive couple. RC is reactive couple. The magnitude which already find out by I omega omega p, and direction is in anticlockwise direction. So this taking moment of RC reactive couple at point at A. So this is in anticlockwise direction. So minus T anticlockwise direction, and again RB into perpendicular distance, again it is in anticlockwise direction. So again it is in minus RB into perpendicular distance. So RB into this perpendicular distance is 150 mm, which is 0.015 meter. So simplifying this equation, 0 into mg is given 52.86, that we have already found out, into perpendicular distance. Torque, value of torque, what is that torque? It is I omega omega p. I into omega p, that we have already found out the magnitude 29.6085. 29.6085 into minus RB, that we have to find out RB reaction at B into perpendicular distance. So after solving this equation, RB value of RB is getting here minus 167.96 Newton. So minus direction is showing the direction of arrow in downward direction. So RB force is acting in downward direction of magnitude 167.96 Newton. And putting the values of RB in this equation, RB we know now. We have to find out RA, and the value of mg we have already found out. After solving this equation, putting the value of RB in this equation, the value of RA is getting here 226.82 Newton, as it is the positive value. So positive value, the direction reaction force is in upward direction. So this is our final answer, RA and RB. So in this numerical, the most important thing is to find the direction of a reactive couple by the procedure which is given in this today's lecture. Okay. So at the end of this session, student can understood how to find out the magnitude and direction of a reactive or gyroscopic couple for given problem statement. Thank you for watching this video.